Hello everyone, Mr. Tomashik here. Today we're going to do the first of a series of labs about electrical circuits using this device right here, a Vernier circuit board, which has resistors, capacitors, light bulbs, batteries, etc. on there, and we're going to do a number of labs with these things. All right, let's get started. All right, in addition to the circuit board, we're going to use a multimeter, which can measure multiple things. If we set it here, we can measure volts. If we set it over here, we can measure ohms. If we set it down here, we can measure amps. Now, when we go in this grayscale here, then we want to have something in this spot and that spot there. We'll talk about these multimeters a little bit more later, but right now we're going to use this one as an ammeter for measuring amps, and we're going to use this one as a voltmeter for measuring volts. Now, before we start, I'm going to take the ammeter and I'm going to use it to test my batteries right here. So if I hook the ammeter to it, I can get 4.9 amps out of it just momentarily, and the other one close to 5 amps. So those are good batteries. Later we'll talk about how measuring the current can actually tell you how good the battery is. All right, how worn out the battery is. Now, we could also use a voltmeter to measure the volts on this, and we'll get 1.48 and 1.50 on that. So we can measure the volts, we can measure the amps. But to test how good the battery is, we actually want to measure the amps. We'll talk about that a little bit more later. All right, let's take a look at what we're going to do in this experiment. We're going to hook up these circuits that we see here. One bulb circuit. Now on the board, these batteries right here are representing this diagram right here. So this right here is the batteries. That's these two things. And then we got 3 light bulbs down here that we're hooking up in this. All the other stuff will come later on there. And the first circuit, what we're going to do is hook up 1 light bulb. All right, let's hook that up once. All right, we have hooked up the first circuit, and in between these two spots here is where the ammeter goes. So the ammeter is set to measure amps, and when I hook it up, the light bulb lights, and we get 0.37 amps. 0.37 amps. So we are looking at the first circuit here, and we have the ammeter hooked right here, and current goes through the first bulb around in the circuit. Light bulb lights. 0.36. 0.36. All right, so we're going to write that in the data table. 0.36 amps. 0.36 amps. All right, so we're going to write that in the data table right there. All right, let's hook up the second circuit. 2 bulbs. All right, so we're going to pull this one down over here, and then we have to have one that jumps from bulb number 2 back up to the plus. All right, now we get 0.28 amps, and it's a little hard to tell, but the light bulbs are lit. They're just very dim, dimmer than they were before. So we get now 2 bulbs and 0.29 amps. 0.29 amps. All right, let's try 3 bulbs. All right, connecting 3 bulbs. We get a current of 0.24, and we can see that the light bulbs are just barely lit. You can't barely even see that they're lit. So each time we added a new bulb to this circuit, the current went down, and the brightness of the bulbs also went down. So 0.24, we can write that in. 0.24 amps. All right, now for the second part here, we're going to keep the 3 bulbs, but we're going to move the ammeter to different spots in the circuit. Okay, for number 3 here, we have our 3 bulb circuit. Now, I connected this to the power supply here instead because these 2 batteries are just not lighting up the bulbs enough to see what we want to illustrate here. So the first ammeter that, now what we're going to do here is just move the ammeters in different locations in this. So each time we're going to measure current in a different location. Now, the first one, what we call I1 here, is the current going through this. So I'll have to open up the circuit and I'll connect to one and then reconnect, and I can get the current. All right, I got to turn this back on. All right, so now I got a new voltage, so my current will be a little different than it was for I1 before. Now it's saying 0.39 amps. All right, so that's I1. All right, 0.39 amps. I'm going to write that in. Now, before we had, what did we have there? 0.36. So I just upped the voltage a little bit so I could get a little bit more current. All right, next then, I'll reconnect that spot once more. All light bulbs are lit. And what I'm calling I2 here now is the current going through this wire right here. So I'm going to open that up. Connect one sort to the meter, back to the spot. 0.41. All right, now it's a little bit different, but we'll see you in the end here. All right, 0.41 amps. All right, reconnecting that one back to the spot again. I3 is this current through this wire right here. So I'm going to open that, reconnect. 0.41. All right, we can write that one in. 0.41. And then I4 is this one way up here. That's the current going through this wire right here. So I'm going to open that up, connect to the electrode. 0.41. Now notice I got 0.41. The very first one didn't say 0.41, but I could try that one more time. I'm going to connect that to this. 0.42. All right, so still a little bit closer. I'm going to change that. 0.42. No, notice they are all very close to the same. All right, which is kind of what we're expecting, because this is a series circuit and there's only one path for electrons to flow, and whatever current goes through one goes through the next, goes through the next, goes through the next. There's only one path for current to flow around that loop, and those currents should all be the same. Okay, let's look at some questions. Number one says, when more bulbs are added to the series circuit, what happens to the total current? All right, that's over here. When we added one bulb, two bulbs, three bulbs, the current keeps on getting smaller and smaller. So when you add more in series, the total resistance increases and the current goes down, All right, so we can say what happens to the total current. All right, we could say decreases. Number two, how does the brightness of each bulb change when more bulbs are added to it? Now, each time I added another light bulb to the circuit, the current got smaller and the bulbs got dimmer and dimmer, until once I had three bulbs, you could barely even see that they were lit. So the brightness of the bulbs decreases as well. Next, what happens if you unscrew one of the bulbs? All right, let's take a look at that. All right, let me get my video back up here. All right, here's that 3-bulb circuit. What happens if I unscrew one bulb? They all go out. Doesn't matter which one I unscrew one, they all go out. All right, in series, there's only one path for electrons, and if one of them goes out, they all go out. If one goes out, they all go out. How does the current compare at various locations? Well, we saw here that the current was pretty much the same at all different locations. All right, now you may get a little bit of experimental error, but the current should be the same in a series circuit. All right, for page 2, what we're going to do here is try to measure the voltage at various spots. Now, we have our circuit hooked up here, and we got all 3 bulbs going. Now we're going to use a voltmeter. All right, so we have this set to measure volts, DC, and the beauty of a voltmeter is that you don't have to open up the circuit to make it work. You just have to touch it on there. So in the first one, I'm going to measure the voltage across the very first bulb right here. So, all right, I just got to touch it on there, and I get 1.86. Now remember, we upped the voltage. We're still using that 1.86. So I can write that in. 1.86 volts. All right, and we're actually using 7.4 volts total. All right, V2 is the voltage. Whoop, I screwed that up. V1 is supposed to be up here, connecting to this spot and this spot. So V1 should be this right here, 5.93. 5.93. All right, let's fix that. Right there, 5.93. All right, V2 then is a voltage across just that one bulb. And I'll measure that by connecting to just that one bulb. 1.71. So V1 is from the terminals of the 2 battery. All right, 1.71. And V3 is across the second bulb. 1.78. 1.78. And across V3 is across the first bulb down here. So I have 1.83. All right, so the voltage across the entire thing, 5.93, and the voltage across just one bulb and just one bulb and just one bulb, all 3 of those are pretty close to the same, and they all probably add up to close to the total right there as well. So this is what we call a voltage divider. So the light bulbs are dividing the total voltage. The first one here is measuring that total voltage, and then each one is measuring just the voltage across one bulb, one at a time. Now, if these bulbs were all exactly the same, then I would expect those 3 voltages to be the same, but they might have a little bit of variation to them as well. All right, that is what we are doing in this part. All right, question 5. To read the current labeled I5, you'll need 2 multimeters. All right, let me hook up that circuit once. All right, number 6 here, we need 2 meters. So I have this one set up to measure volts, and it's measuring the voltage that we measured before as 5.93. Now I hooked it up a little bit differently, but it's still measuring 5.82 volts. All right, and that's across all 3 of them at the same time. Now what we're trying to do here is actually measure the current going into that voltmeter. So to do that, I'll have to reopen this circuit and insert this ammeter, right, to measure amps. Insert that ammeter in line. Now notice the voltmeter goes back to reading 5.29, something like that, but the ammeter reads 0. All right, reads 0. Now let me switch it to a little different scale. All right, if I put it over on this setting here, now I can measure milliamps, and when I connect it, the voltmeter reads, but the ammeter still says 0. I'm going to switch it one more time. Now I'm measuring microamps. In this case, I get something. So now I can measure a very small amount of current, 5.9 microamps. 5.9 microamps. All right, let's jot that down. So the voltmeter reads 5.91, and the ammeter reads 5.8 microamps. That would be 0.0000058 amps. 5.8 microamps. All right, we'll talk about why that is later. What the reason for that is that a voltmeter has an infinite amount of resistance, theoretically, and should draw very, very little current. All right, back to the questions. Number 1 says, voltages 2, 3, and 4 are the voltage across each bulb. How do they compare? All right, that is this right here. They're pretty close to the same. All right, let's just write same. All right, if the bulbs were exactly all the same size, then they would be the same. How does the voltage V2, 3, and 4 compare to V1? All right, if we add up V2, V3, and V4, what do we get? Those all add up to 5.32. Now, theoretically, those should add up to what V1 says. Now, there's reasons why it didn't, but that has to do with the fact that those wires have some resistance too as well. All right, but if we added them up, we should have gotten equal to V1. So how does V2, 3, and 4 compare to V1? V2 plus V3 plus V4 should have added up to be V1. All right. All right, page 3. Now, instead of light bulbs, we are going to connect to resistors. Remember our resistors from before with the little lines around them, and we had our color code? That's what these things are here. And we're going to hook one up to a 10 ohm and a 51 ohm. Now, I'm going to keep it hooked up to that power supply over here. Not quite as exciting because when current flows through a resistor, you can't even tell unless you put a lot of current. It might start smoking. All right, so we won't be able to really see anything except when we use our meter. And let's see what we're supposed to measure here. In the diagram, we have voltmeter showing up twice and 3 ammeters. Now, let's do the voltmeters first because that's just connectable without disconnecting anything, and we can just take and measure the voltage across the first resistor, the 10 ohm, and it will read 1.08. 1.08, so we can write that in. 1.08, that's in volts. And V2 is across the other resistor, so we will measure that, and that comes out to be 5.42. 5.42. 5.42. Didn't look very good there. 5.42. All right, now if we add those together, I get 6.50. 6.50, which should be the power supply. But because the wires got resistance, it does not happen as such. Next, we got to read the current called I3, I1, I2, I3. And for that, we'll set the meter back to measuring DC amps. And then we have to open our circuit in the various locations. I1 then would be the current that is flowing through this wire. So disconnecting that, back to the spot. Oops, I got that in the wrong place. All right. 0.10. 0.10 amps. I2 is the current through this wire. I'm going to open up that, connect that, 0.10, 0.10. And then the third one will be the current through this one. Expecting 0.10, 0.10. So the current in all three locations, 0.10, 0.10, which is what we expect. They're in series with each other. All right, question, how do I1, 2, and 3 compare? All right, it looks to us that they are the same. Using a voltage across R2 and R3 and the current through each, calculate the resistance of each with Ohm's law. All right, so the current through each one is 0.10. The resistance would be V over R. So for V1, I got 1.08 divided by 0.1. All right, so that gives me 10.8 ohms. And that's what that is, 10.8, a little bit of experimental error. All right, the second one, 5.42 divided by the current through it, 0.1, gives me 54.2 ohms, and it's 51, so within the tolerance, comes out about right. All right, now, what else can I do with a multimeter? All right, multimeters can be set to read resistance directly. Now, when we do that, all right, we're going to hook this up, our multimeter, to measure ohms. All right, we're going to measure ohms, and I have to be in these two slots right there. All right, to measure ohms. And then I can measure the ohms between the two terminals. All right. Now, with this, you don't want to have it hooked up to any kind of a power supply. The ohm meter sends out its own current and measures the current through stuff. All right, so I'm going to disconnect the two resistors, and then I'm going to measure the ohms between the two. And it says 60.8. 60.8. All right, that's between two of them. Now, if I measure one individually, it says 10 ohms on the label, and my meter says 10.1. 10.1. On the other one, it's 51 ohms on the label, 50.2. 50.2. All right, so I can write that in. 50.2. And the other one, I forget what it was here. Let's do that again. 10.2. 10.2. All right, so according to an ohm meter, this is what we get. And the label on one was 10 ohms. The other one should have been 50 ohms. So we can also measure resistance. We can measure resistance, just like the resistance of this little squiggly wire that we had the other day. So I'll measure the resistance of that. 3.8. So that little coil up piece of wire has a small resistance, and when I run current through it, I can get it to possibly glow. Let's try that and see how much current it takes to actually make it glow. 1.5 amps, 3.48, that's as much as I can get. And there it is, glowing red hot. All right, to page 4, extension questions. I'm going to leave that for you guys. If you have questions, then of course you can ask. And that'll do it. All right, thanks for watching.